So interval notation is a way to write domain and range, or just ways to write intervals of numbers to begin with. Anytime you write domain and range in this class, it needs to be in interval notation. If you do not use interval notation, you will lose points. So the alternative to interval notation is inequalities, where you say like x is less than 3 is less than 5 or something like that. X is between 3 and 5. You've done with inequalities before. Now we're just going to use this notation instead. So we're going to talk about how one can kind of transfer to the other. So if you see a open circle on a graph, okay, or you see a less than symbol, or you see a greater than symbol in an actual inequality, any of those things, we're going to use parentheses in our interval notation. Why is that not showing up? I'm writing it. There it goes. I was wondering why none of you were writing anything. Okay, so open circle, that's not a 0, open circle, less than, greater than, we're going to use parentheses. If you see a closed circle, less than or equal to, greater than or equal to, any of those, we're going to use a bracket. So parentheses, brackets are going to be our square ones, like that. Okay. If there is an inequality that continues infinitely, so it never ends, it goes forever in one direction or the other, you will use a positive or a negative infinity symbol. Positive infinity represents far on the right, or a really big number. Negative infinity represents far on the left, a really small number. So there is a difference between the two. When this happens, you must use parentheses, okay? Infinity is not a number. It's this idea that we approach. We can't ever equal infinity. So that's why we always use parentheses, because parentheses are used when something is not equal. Okay, interval notation must be written from smallest to largest, and the values are separated with a comma. So let's say, for example, I wanted to say this. Okay, so you've written things like that before. Inequality symbols always point in the same direction at the smaller number if you have an interval like this. This means I want all the numbers from 0 to 3. 0 is not included, but 3 is included. My interval notation would look like this. Parentheses, 0, 3 with a bracket. Anywhere it's equal to, we use a bracket. Anywhere it's not equal to, we use a parentheses. Or let's say I wanted to say 4 is less than or equal to y is less than 7. Okay, that would look like 4 with a bracket, 7 with a parentheses. Okay, and we would know it's an x and a y based on if we're doing domain and range when we get to the problems. Okay, or let's say I wanted to just say y is greater than 8. Okay, so what would that look like? I want all the numbers from 8 all the way to positive infinity, or all the numbers that are bigger than 8. So 8 to positive infinity. 8 is not equal to, so it's a parentheses. Infinities are always in parentheses. Let's say I wanted x's less than or equal to -3. Okay, so that's -3 and all the numbers below it. So all the way down to negative infinity. That would look like negative infinity to -3 with a bracket. Notice I'm always writing the smallest number on the left and the biggest number on the right. Negative infinity is the smallest number you can have, a false idea we can approach. Positive infinity is always the biggest. Any questions so far on the notation? How many of your teachers used this before? Any of them? Couple? Maybe about half? Okay. Some teachers do, some teachers don't. Some just use the inequality symbol. All right, other big ideas that we're going to talk about today, or review really, mostly. Domain is the set of all your x values. And remember, x values, it's not always an x. If we have different variables, it's just our inputs, okay? And then range is the set of all y values, or our outputs. Okay. If we are looking on a graph for my domain, my set of all my x's, think about your x-axis. X values go from left to right. So to calculate the domain of a graph, you're going to look from left to right. The smallest number is going to be where your domain starts. The biggest number is going to be where your domain ends. And then range is the set of all your y values. So on a graph, you're going to look low to high. The smallest value is where your range begins, and the highest value is where your range ends. Questions? Good. All right, let's practice some. Okay, find the domain and range, write your answers in interval notation, and then I have some little things we'll evaluate on the graph too in a minute. All right, so let's start with domain of this graph. So domain, we're looking from left to right. How far to the left is this graph going to go? Forever, right? It's got an arrow on it. It's just going to keep extending up and forever to the right or to the left. And then to the right, same thing, forever, okay? So in the past, you might have written in words all real numbers. Now, if the answer is all real numbers, we're going to say negative infinity to positive infinity. Okay, that includes everything. Range. Now we're looking low to high. What's the lowest y value that this graph reaches? Perfect. And we're assuming, because there's not an open circle at the bottom at the vertex there, that it's a closed dot. Okay, unless you see an open dot, you can assume that there's a closed dot there and it's a point, which means we're going to use a bracket. 1 is the lowest, and then how high does this go? To infinity and beyond. Okay, and there's my range. Okay, we can also evaluate the function from a graph. If I say f of -1, this is kind of a review from yesterday. Remember, the number inside the parentheses is an x, and you're looking for the other half of the point, the y. So you can use the graph to help you here. It's saying x is -1. Here's x is -1 on my x-axis. Then you go up or down to the graph, which in this case, the graph is above. How high do I have to go to hit that graph? I have to go 1 unit up. So f of -1 is 1, which just tells me -1, 1 is a point on that function. Okay? Any questions on the first one? Okay, let's look at letter B. We'll do a couple more together. Domain. Left and right. How far to the left does this graph go? Not infinite this time. We don't have arrows. Arrows are going to be your clue to infinite. To what? -1, and would I use a parentheses or a bracket, do you think? It's going to be a parentheses at -1 because of that open circle. Remember, see an open circle, it's a parentheses. And then how far to the right does this graph go? 2, will 2 be a bracket or a parentheses? Bracket. Okay, let's look at the range. How low does it go? -2, bracket or parentheses? Bracket. Because we assume if there's not an open circle there that it's a closed dot, okay? And then how high does it go? 3, parentheses or bracket? Oh, 2, I'm sorry. Yep, those are kind of tiny numbers, you're right. 2, and then parentheses or bracket? Parentheses, okay? Evaluating the function notation says evaluate f of 0. So that means my x is 0. What's the other half of the point? 0 what is on this graph? What is it? -1. Perfect. That's that point right there. 0, -1 is on this graph. Okay. Let's see here. Let's do one more together. Let's do letter E together. Then I'll let you try the other 3. Okay. All right, so this one's a little different because it's not what we call a continuous function. There's different pieces that we have to worry about. Let's start with the domain. Okay, so there's going to be 2 separate pieces that make up our domain. Let's start with the little like diagonal line segment on the left there. What's the furthest to the left that goes? -3, bracket or parentheses? Bracket. All the way to what number in that little line segment? 1, and again, bracket, because it's a closed dot. Then my graph jumps, okay, and we'll talk about what to put in the middle here in a minute. It jumps to what x value? 3, bracket, and then it goes forever to the right, to infinity, and infinity always has what? Parentheses. If you have different groups in your domain and range, we're going to put a U between them without the little line on it. U means union. It means both of them put together. It's set notation. Okay? And you can have multiple groups. You can have like 7 groups that make up your domain if there's 7 segments on your graph. All right, low to high now, my range. What's the lowest this graph goes? -1 on that first segment, and then it goes up to +1, and then it jumps, U. It jumps to what Y value? 4. Does it go higher or lower than 4? It does not. So there's 2 different ways you can write this. The first way is you can just say 4 to 4, which is a little redundant. So most of the time, what we write instead, and what MathXL is going to want you to write, is a 4 with our little squiggly set brackets. Just saying it jumps to 4, but it's just that single number. It doesn't go higher or lower than that. Okay, so if you have a single number, you're going to write it like that. Okay, now the function notation at the bottom. It says f of x equals 0, find x. So remember, f of x is a fancy way of saying what? Y. So in this little question, I have the y coordinate of my point, but I don't have the x. So which point on here am I looking for? What x value goes with a y value of 0? -1. That's that point right there. That point has a y coordinate of 0, but an x coordinate of -1. So that's my answer, -1. Okay, see if you can try the other 3 graphs on that front page with your partner or a group near you, okay? Domain, range, answer the function notation. All right, let's check and discuss. So for letter C, I didn't put a function question on that one, but your domain, just left to right, 0 to 10, range, -9 to 5, everything should be brackets. Good on that one? Or not really a circle, it's an oval. Yes? Any questions on that one? Yes.
I put 5 to -9, like, I don't know.
Technically correct, so it means the same group of numbers, but the notation isn't right, because it's got to be smallest on the left and biggest on the right. Yeah. So it's still the same set. Okay. It's kind of like if you wrote with inequality symbols, but you put your inequality symbols backwards. Okay. Anything else on C? Okay. Letter D then, domain left to right. It starts at -1, but there's an open circle, so parentheses. It goes forever to the right, so positive infinity with parentheses. My range goes to -2, and then every number, even though there's that open circle there, there's another place on the graph where that is defined at. So every number from -2 up has a value on this function. So -2 with a bracket all the way to infinity. And then this one's tricky. This means y is -1. There are 2 places on this graph where I have a, you can even like put your horizontal line there if you want to. I have a y value of -1. There's 2 positions on that graph. You gotta look everywhere left and right. And that happens when x is 0 and x is about 1.5. Okay. And then at the bottom, this one's also a little tricky. So your domain, if you have written, actually, let me show you on here what it would look like. If you have, let's see, -infinity to -1, -1 to 2, and 2 to infinity, that is not wrong, okay? You just took all 3 little groups and listed them separately. But isn't every x value defined there somewhere? Like if it stops at -1 and then starts again at -1 and there's a point there, those can be squished together. Does that make sense? Okay, so long way, short way. Everything from -infinity to infinity is defined. Yes?
What about the -1?
So if I'm looking at range, would it be the same as E?
Because on E you have the 4 and like the things.
Yes. But it's not, in this one, we jumped, and in that segment, that was the only Y value it hit. I don't even actually have to worry about this guy at all, because this guy is including that -1 already in it, okay? Oh wait, but that should be a bracket on that one. Is that what you were asking me?
No.
Or no? Okay. It should be a bracket though, because even though there's an open circle there, -1 is defined, okay, because I do have values on this line, okay, and then it jumps from 1 to 5. Okay, that one, x value of 2, you could technically look at 2 points there, but open circle means not equal to, there's no point. So we're just looking at this guy, and the y value of this is 5. Any questions? In range, correct. Okay, flip your paper over. The next ones are going to be pretty quick. So let's say I have domain and range of like a scatter plot or those correspondence diagrams we saw yesterday. If you don't have a group of numbers, continuous values in a line, you are listing values separately. So like for this scatter plot for my domain, I would just list all of the x values. And it looks like it's just 45, 55, 65, 75, 85, 95. Notice I'm using those squiggly brackets just to show that it's independent. Now you could list it like that, or you could list squiggly brackets around the 45 and then union, and then squiggly brackets around the 55 and then union, but this is a little more condensed, so we'll usually do this. Range is the same thing. Only difference now is we're using the y values. If I'm listing my y values, it just looks like it's 2, 4.5. No, that's not 4.5. That's a 5 on this graph. 5, 7, 8, 10, 12. Just listing them out. Nothing crazy. Correspondence diagrams, remember, just mean points. It tells you when the arrows are connecting that an x and a y go together. So as long as you remember the first bubble is the x's, the second bubble is the y's, domain is our x's, range is our y's, we just list them. So my domain is A, B, C, and D. My range is 1, 3, and 4. Why did I not include 2? Grace? Yeah, it's in the bubble, but it's not actually part of any point in this function that's being represented. So we do not include it in our range. Any questions on those? Okay, you might see a problem in Math Excel that says find the range of a function given the domain. Here the domain is actually 5 different values. It's all x's, remember. This is essentially just like filling out a table like we did yesterday. You have the x's. That's your domain. You are missing the y's. That's your range. So you need to plug all the values in. Or if you have a graphing calculator, you can put your equation in y equals and then look at the table of values to get it quickly. So that's up to you. I'll just do let's just do them real quick. If I plug -2 in, I could do these in my head. That would be 4 times 2 in the first term would be an 8 minus negative, so it would be +4 plus 5, that would be 17. If I plug -1 in, my first term would be 2, my second term would be 2, my last term would be 5, that's a 9. If I plug 0 in, that one's easy, just gives me a 5. If I plug a +1 in, the only thing that's going to change is my middle term is going to be negative, so 2 minus 2 plus 5 will also be 5. And then if I plug in 2, I'll have 8 minus 4 plus 5, so that's 4 plus 5 gives me 9. So my answer for my range is just all of those y values, 17, 9, 5. And actually, because I have values that repeat, range is the set of all of your y's. I already have 5 and 9 included. You do not have to write them twice. Okay? Questions on any of those? Those are fast. All right, last thing we have to talk about today is, let's say you don't have the graph or a table or a correspondence diagram and you have to find the domain from a function. Now notice these are only domain. Range is a much harder question when you have a function, and we'll talk about that like at the very end of this chapter. So all of these are just domain questions. When you talk about domain, we're talking about what is x allowed to be. And there are 2 things that x cannot be. I'm actually going to put them in the little big idea bubble on the other side here. So when we're talking about domain, you cannot have a 0 where in a function? In the denominator. Okay? So that will cause a mathematical error when we divide by 0. So we're going to hunt for those. What will cause a 0 in the denominator? And then the other domain issue we're going to encounter is you cannot have what under a square root. You cannot have a negative number in a square root. So that's the other piece we're going to hunt for. What x's would potentially give me a negative under a square root or give me a 0 in the denominator? Those are what we call domain restrictions. Okay? Once you locate your restrictions, your domain is just everything else except those numbers. Okay? So those are two things you're going to look at in every problem. And they won't apply in every problem. Sometimes it'll be one or the other. Sometimes it'll be both. Sometimes it'll be none. Okay. So let's look at letter A. Two things I'm looking for. Do I have a denominator in this problem? No. Do I have a square root in this problem? No. So am I going to have any domain restrictions? No. So my answer is what? Negative infinity to infinity. Those are the easiest ones. No denominator, no square root. Your domain is all real numbers. Now, if you wanted to think about the graph of this, that's a parabola. The graph of the parabola, imagine any parabola opens up or down. It's going to go forever left and right. Okay? All right, let's look at one that has a denominator now. That numerator, I do not care about. I only care about this denominator to figure out my domain restrictions. Now, you might be able to, in your head, figure out what number, if I plug it in for x, would make that whole denominator equal 0. Right, if I put 1 in there, wouldn't that make the denominator 0? So we don't want to think plugging 0 in for x, because 0 minus 1, that's okay. I'm allowed to have a negative 1 in the denominator. But what number will make the whole thing equal to 0? And if you don't see it, here's what we're going to do. We're just going to set our denominator not equal to 0, because that's what we do not want to happen. And then we solve that little equation. X cannot equal 1. That's our restriction. Now, let's imagine a number line. The whole number line is shaded, except that 1, I have an open circle. Anything that's shaded is my domain. So there are two groups there, numbers smaller than 1 and numbers bigger than 1. So I'm going to put those in interval notation. And actually, I'm just going to write it above my number line here. Negative infinity to 1. 1 is an open circle, so it's a parentheses. Union, because it jumps. 1 to infinity. So when you have a single number that your domain can't equal, look at what I have here. On the ends, it goes from negative infinity to infinity, but I have a break at 1. It jumps over 1, saying everything except 1. Does that make sense? Okay. So let's do a couple more with the denominators, and then we'll come back to the square root ones. Okay, let's look at letter E. Okay, my denominator is starting to get a little tricky now. Remember, you do not want your denominator to equal 0. That's bad. So how do I solve for x? What do you do? First step. We can do this. Come on. Add 9. Then what? Square root. X cannot equal, what's the square root of 9? Plus or minus 3. Okay? If you're not sure what that's going to mean, think about our whole number line is shaded, except -3 and +3 are my two restrictions. So how many groups am I going to have when I write my domain? I have 3. I have 3 sets of numbers that are shaded on that number line. Negative infinity to -3 is the first group. Then it jumps over -3, -3 to 3. Then it jumps over 3, 3 to infinity. So every restriction you have in these denominators is going to create an extra set of numbers when you write your notation. Okay. Let's look at F. Swallowed the wrong way, excuse me. Now, when you have a negative out front of a fraction, you can put it in the numerator or the denominator. It doesn't make a difference. Just don't put it in both places. Here, I'm going to put it in my numerator because I don't care about my numerator. So it's going to make my calculations easier. Okay. Remember, we don't want that denominator to equal 0. Okay. how would you solve something that looks like that? It's a quadratic. It's already equal to 0. Can I factor that? What can I factor? What can I do? Take an x out. Take out what they have in common. That leaves me with x minus 3. And then if I set each of my factors equal to 0, from this guy I'm going to get that x can't equal 0. And from this guy I'm going to get that x cannot equal 3. Another section where factoring has come into play. We will do factoring almost every day in this class. I promise. They're going to put it in places that you're like, I didn't even know we could factor in that situation, but we are. All right, so maybe you can do it without the number line this time. Negative infinity to, imagine your number line. What's the first number we're going to jump over? 0. And then we're going to go to what? 0 to 3. And then we're going to jump over 3 and go from 3 to infinity. Have I used brackets in any of these problems yet? No, I have not. It is always parentheses. Okay, let's go back to the square root problems now. Let's say you have a square root and we want to figure out what is x not allowed to be. Okay, well, whatever is under my square root must be what? So close. Positive or 0. Can I take the square root of 0? Yes, you can. What is the square root of 0? It is 0. It is defined. It is not a mathematical error. Okay, so here's how we solve for it. X plus 3 must be greater than or equal to 0. The stuff under the square root must be positive or equal to 0. How do I solve for x? How about I just move the 3 to the other side? Okay. Now here's how you can see if this makes sense. Plug in a number that's bigger than negative 3, like negative 2. Negative 2 plus 3 is positive. We're good. Plug in a number smaller than negative 3, like negative 4. Negative 4 plus 3 is negative 1. That's bad. Okay? So this is your domain when you get these. It's not a restriction. That's what x has to be. So your domain, I need to put that in interval notation now, is negative 3 with a bracket now, because I am allowed to equal negative 3. Negative 3 plus 3 is 0. I'm allowed to take the square root of 0. And then it's everything above that, positive infinity. Okay? Let's look at letter D. Again, only thing we care about is the denominator, which 3 is not a variable there, so that's not going to do anything. But my square root, what's under my square root, has got to be greater than or equal to 0. It's got to be positive. So what does x need to be? Greater than or equal to negative 4. Let's pretend, just pretend, don't write this down, there was a negative in front of that x. What would you have to do to get the x alone? Divide by negative. Do you remember what happens to an inequality sign when you multiply or divide both sides by a negative? The sign flips. That might pop up in your homework. Okay? If you multiply or divide by a negative, just remember your sign flips. So that's my domain. In interval notation, it is everything greater than negative 4 or equal to negative 4, so negative 4 to infinity. Last two. Let's look at letter G. I've got two problems here. I have square root and a denominator. What is an x not allowed to be in the denominator? X can't be 6. Okay, if you set that equal to 0, you're going to get x is 6. The numerator, I can't have a negative underneath it. Okay, so let's take my numerator. It's got to be greater than or equal to 0. Oh, that's lagging on me. That's a 0 there. Okay, solve for x. 2x is greater than or equal to 3. So x is greater than or equal to, you could say 3/2, or this decimal's pretty, 1.5. Okay, I'm going to draw this one on the number line. I am allowed to have in my domain every number from 1.5 to infinity, but I am not allowed to include 6. Okay, how many groups of numbers are going to be in my interval notation? 2. Anything that's shaded is part of your domain. So my domain is 1.5. Then I'm increasing, but I have to jump over 6. I'm not allowed to equal 6. And then, come on, computer, 6 to infinity. It's like telling me you've talked too long, you're almost done. Okay. Does that make sense? If you're not sure how to put it in the notation, shade on the number line. Last one. My square root is in the denominator. So now what's under my square root can't be negative, but it also can't be 0 under my square root, because then it would be a 0 in the denominator. If you have a square root in the denominator, it's going to look just like the square root problems. You're just not going to say equal to anymore. I'm not allowed to equal 0 because it's in the denominator. So x has to be strictly greater than -5, which my domain would be then -5 with the parentheses all the way, come on, positive infinity. Okay, that's it. Domain, range, function notation, interval notation. What questions do you have? Do we have questions? Okay, I have an exit ticket. Yes. That's why it's parentheses. Okay. Because when you're solving, you're not going to use equal to. That's the only case it won't be equal to, because it's. Okay. All right. We are going to check the answers to this at the beginning of the period tomorrow. So you guys have 10 minutes now. You can work on this if you want to. You can take it home and try it tonight, and then we're going to check answers at the beginning of the period tomorrow as like a warm-up. Okay? All right. Here we go. 1, 2, 3, 4, 5, 6. I'll do the cell phone motto. Last 10 minutes for your 1, 2, 3, 4, 5. There you go. 2 for Math Excel, by the way, is due on Thursday. One more. Oh, yeah. Mm-hmm. Okay. Yeah. Those are both. You look at this one. So if on one side you are allowed to equal it, then that's 2. But all of these domain questions, they're all correct. You're never allowed to equal. If you have 2 brackets, yeah. Okay. All right. As long as it's defined on one end or the other, it's good. Okay. 1. Nowhere. Need a star one, and everybody wins. I know. Okay, Math Excel due Thursday.